Alright, this is a video about reaction time. I'm going to show you a stopwatch. This, you're used to calling a ruler. I'm going to call it a stopwatch. In fact, it's a better stopwatch than a stopwatch. And the way I'm going to use it is by having this stopwatch calculate an amount of reaction time. Alright? The way you do that with one of these here guys is hold it vertically and just let it go. Someone should write a song. When you just let it go, gravity obviously pulls it down, and what you'll learn, or you already know, is gravity is a very constant acceleration. It treats everyone and everything exactly the same. It's quite democratic, actually. So the distance between where your fingers are right before you catch it and then as it falls and you catch it, that distance is very easily measurable. And based on that distance, you can calculate a time. And so it's a very, very good stopwatch, better than any given stopwatch. So this is about reaction time and what I call formula, because I've talked about the first three formulas. I have not gone to the fourth one yet. This is the fourth one, okay? Now, what we know and don't know with this particular situation of just dropping something that's fallen. In our example now, we have a yi, the initial location, and we usually reference the 0 mark of that ruler. So that happens to be 0, and I'll put it in meters. Now the YF is where my fingers would snap together to catch that particular ruler. Okay? For the math here, I just picked a number. You can't really see it, but I'm going to call it 18 centimeters. But I'm going to do two things with that number 18. First of all, I'm going to call it 0.18 meters. And secondly, what I would like you to realize is the ruler was falling down, and that is negative. So it's 18 centimeters below where it used to be. Alright, so that's why I did that. Also, I'm using Y's instead of X's. Last videos I showed you about XI's and XF's, but we're no longer moving horizontally in this Y example. We're moving in a Y. Okay. I have a VI, the initial velocity at the instant I let that item go is 0 meters per second. VF, the speed at which that ruler was falling at the instant I snapped my fingers together to catch it. I have no idea what it is. So that's a question mark. It's not a goal. It's not what I'm looking for. I'm looking to calculate time. That's why I didn't write anything there other than a question mark. This is an unknown, and it's uninvolved in the question. The acceleration that that ruler felt is the acceleration due to gravity, which you all know is 9.8 meters per second squared. And in the same tradition of making this a negative 0.18, reminding yourself that gravity listens to my favorite band, One Direction. That means it only acts in one direction, and it's the negative y. So that acceleration is going to be a negative 9.8 time. That is our goal. So please learn or remind yourself to distinguish between those two, what your goal is and things you just don't know. Okay? So in this particular problem, if we go looking for an equation here, what we would do is look for something with yi's, f's, a's. We don't want a vf in there. We got a vi. We want some t's. We're accelerating, all that sort of stuff. Well, Formula 1, you know, is xf equals xi plus vt. That's only true if it's a constant velocity. Well, gravity is an acceleration, isn't it? So I'm not going to use Formula 1. Formula 2 is simply the average velocity formula. V is equal to VI plus VF over 2. That doesn't help us because there isn't even a letter T in that E equation. So I can't use the deuce. So now what I will do is write Formula 3. That's the one that has a VF is equal to VI plus a T. All right? The VI is 0, the A is negative 9.8. Time is what we're looking for. But you see that VF, I don't know the VF. So I have two things I don't know in this E equation. So I can't use Formula 3. Well, that means there needs to be a fourth mula, and that's why I'm calling this formula. So I'm going to start with Formula 1, and I will end up with formula. With, ooh, see, with. To obtain formula, start with Formula 1. And what I just wrote again for you is xf is equal to xi plus vt. Now, what I'm going to do is have a swapper tuna v. This v I will put Formula 2 in where that v is. So it will just be vi plus vf over 2. All I'm going to do is just put Formula 2 inside that red box. Let me write this down here. Boom. Sub in Formula 2. So what I now have is xf is equal to xi plus vf plus vi over 2, and then I need to multiply it by t. All right? That's easy, isn't it? Then the next thing I'm going to do is one more swapper tuna v, where this VF is, or I guess I could put an I and F, it would make it a little easier, it doesn't matter. Where this VF is, I'm going to sub in Formula 3, because Formula 3 is VF is equal to VI plus AT. So, what I will do now is exactly that. XF is equal to XI plus Formula 3 in blue, VI plus AT plus VI. This is still all over 2 T. All right. Now all I'm going to do is start to simplify it. That's all I'm going to do. It's pretty easy, really. VI plus VI. That's 2VI. Plus AT. This, I'm going to separate that 2 because of those plus signs. Over 2, over 2. Because of that plus sign. Now you don't need to. I just did it so it helps you visualize that dies, right? And don't forget that T is still there. Okay? So what do we have? We have an XF is equal to an XI plus VI with that T distributed, plus I'm going to write that 1/2 AT, and this is distributed there also. XF is equal to XI plus VIT plus 1/2 AT squared. That's formula. So please, wheeze, remember that. That's formula. Okay? So, to use it in that reaction time, calculation. Remember, I'm just going to rewrite it with y's. Remember, I had a yf instead of an xf. It doesn't matter. It depends if you're moving on an x-sus or a y-sus. Is equal to yi plus vi t and 1/2 at squared. Okay, so remember our y's method. There, the w is what I did up there. So I'm going to, again, where this is, there's my w, that variable list. That variable list led me to identify this, and I will now isolate the equation, the version of it that we're looking for here. Come on. Come on. So, remember, the yi was 0, so I'm going to call that 0. And remember, vi was 0 also. If vi is 0, then it doesn't matter what this t is. Anything multiplied by 0 is even more nothing. Okay? So, what I now have is yf is equal to 1/2 at squared. So now what I'm going to do is rearrange this equation. That means I'm going to multiply the 2 over. I'm going to divide by a, and I'm going to square root. Okay? So what this ends up looking like is 2 times yf divided by a square rooted equals t. Do that. Do math with letters. For gosh sakes, people, do math with letters. Do math with letters. Now, the S is the substitute and solve part of the show. It's 2 times the YF. Remember, the YF was negative 0.18 meters. Okay? Now, don't worry about that negative under a square root, because you know that acceleration is also negative 9.8 meters per second squared. Okay? And square root that equals t. All right. Now, when you do the math, for gosh sakes, people, do the math all at once. Don't baby step through this. Your magic box is quite full of mojo. It can handle that calculation if you do it all at once, I promise. Type it like this. Just like this. Square root, it will give you a parenthesis. Use it. You don't even need a second one. 2 times negative 9.8 divided, ooh, gosh, jeepers, V. Oh, I'd owe you push-ups, times negative 0.18 divided by negative 9.8, and then close the parenthesis, enter. That's it. That's all you got to do. Do the math all at once, and the answer is 0.19 seconds. All right, 0.2 of a second-ish. Does that sound reasonable? And I would say yes. Please, whoops, here, let me write that in red. Evaluate. Whoop, come on, boom, bang, It makes sense. Please don't leave it as, say, 0.02 seconds. That's a tad fast. And gosh, sometimes students say it took them 2 seconds to do something like that. Don't do that either. But please get in the habit of doing that math. That's 4 mu